All right, today we are starting to look at transformations of graphs. So we're going to be having shapes that we're going to be transforming. So there are four main types we're going to look at. There are rotations, reflections, translations, and dilations. Today we're just looking at two. We're just going to look at translations and reflections. So the first one, a translation, this is where all of the points are going to move in the same direction, the same amount. Easy word for this is the picture will slide. So the points will all move right 3, up 4. The points will all move left 7, down 2. It's making that same movement. So if we look at this picture and we want to go from point P to the new P, this little apostrophe means P prime, the new P. We would see how many over do we go and how many down do we go. So when we count over, we count 1, 2, 3, 4, 5, 6, 7, 8 over. And then when we count down, we've got 1, 2. So we went down 2. How you'll put this for the math terms or math talk is you're going to have a big T for the translation, and then in the little at the bottom, you'll say how far it goes over and how far it goes up or down. And that will tell us how to move 1 point, X or Y. So all it means is you can take X and add A to it, and then take Y and add B to it, and you'll get the new point. So here, old point P is -3, 4. And if I take -3 plus 8, it should get me +5, which is where I end up. And then if I take 4 plus -2, it gives me 2. And if I look here, I've ended up at 2. So this is the math talk to essentially tell me how many over, how many up or down. So you can think A is my over, B is up, down, is what that's telling us. So let's look at an example of this. Here we have a picture and we have a triangle PQR. And we have been given the rule T of -2, -5 for triangle PQR, which is this picture right here. So if we remember, -2 tells us where we go over, and -5, since it's negative, it will not be up, it will be down. So this tells me I need to go down pieces. So again, that first number is how many over. Since this is a negative, again, I want to go backwards. And -5 means I'll go down 5. So if I look at my graph, I need to move all 3 points because I want to be able to draw triangle P prime, Q prime, R prime. Again, this little notation here, prime, means new, the new point P. So for point P, I want to go back 2. I'm going to go back 1, 2, and down 5. 1, 2, 3, 4, 5. This will be my new point. Then I do it again with point Q. I go back 2, and then I go down 5. 1, 2, 3, 4, 5. Here I have my new Q. And last but not least, I have R, and I'm going to go back 1, 2, down 1, 2, 3, 4, 5. I'll put another dot, my new R. And if I connect these 3 dots, I get another triangle just like my first one. All we did was slide it back and slide it down. So that's a translation. It's a slide. And the other one we're going to look at today is a reflection. So a reflection, it's like what you see in the mirror, and a reflection flips everything. So here you can see the star has flipped from the left, and it flipped over to the right. So again, if we think about the math talk for this time we'll see an R, and down here it will tell us what to flip over. So it might say the x-axis of point X, Y. Maybe it'll say the y-axis, but it tells us where to flip the picture. So let's go ahead and look at an example of a reflection. So here we have an empty graph and we have a table. So we have the pre-image. So the pre-image is the old, and then the image will be our new. So we want a reflection over the x-axis of triangle X, Y, Z. So that means we need to draw triangle X prime, Y prime, Z prime. So for the reflections with the flip, it's not as easy as a slide where it tells you go back this many, down this many. But there is a rule that you can always follow. If you're reflecting over the x-axis, you will have an opposite x value, but the same y value. And then if you're flipping over the y-axis, you will have the same x value. I got these backwards. If you're flipping over the x-axis, you have the opposite x. Nope, I had it right. Y'all are gonna think I'm crazy. I'm crazy even in my videos. X-axis is the same x, opposite y. Y-axis is opposite x, same y. Yes, I have it right. I don't remember what I said. X-axis, same x, opposite y. Y-axis, opposite x, same y. So here we are looking at flipping over the x-axis. So I want to pay attention to this rule right here. I want the same x, but the opposite y. So if I look here, I want all of these x's to be the same. So I still want positive 2, I still want negative 4, and I still want positive 3. But for my y's, I want the opposite. So that means if this is a negative 1, now I want a positive 1. If this is a negative 3, now I want a positive 3. This is a positive 2, now I want a negative 2. So when I go to graph my new picture, I'm going to do it all in one color. So for my new x, I go over 2, up 1. For my y, I go back 1, 2, 3, 4, up 3. And for my z, I go over 3, down 2. So here is my new triangle. I'm going to graph the old one just so you can see the flip. So the old image was at 2, negative 1, negative 4, 1, 2, negative 3, and positive 3, 1, 2, z. So if I connect these here, you can see here's my x-axis, and the y went from bottom to top. My x went from bottom to top. My z went from top to bottom. So they all flipped spots over the x-axis. If they were on top, now they're on bottom. On bottom, now they're on top. All right, if you have questions, please ask, let me know, and go ahead and try the practice that is in Google Classroom.